Hey, let's discuss one of the problems which is commonly asked nowadays in interview, and this problem is known as the maximum path sum. We all know the problem in a binary tree is this problem where, let's say, this is a binary tree, and if you have to find a path with a given sum, we know the path starts at root and it's at the leaf node. That is commonly known problem. We all have figured out the solution for this. This problem is bit unique. It says that the path may not pass through the root. So that means the root may not be in the path which has the maximum sum. So for example, if I give you another tree, let's say this, in this the maximum path we can get is from node 15 to node 20 to node 7, and this is the path with maximum sum of 42. If we include 10, then the path at this particular point will be either minus 10, 20, 15 or minus 10, 20, 7 based on whatever maximum we choose. So maximum will be, if I include minus 10 as well, the maximum will be 25 sum. So if the path passes through the root, it's not a greatest value, or it is not the maximum path. So the idea here is to find a path which has the maximum sum, and this path may not pass through the root, and this path is between any two nodes in the tree. So in this case, the path was between 5 and 7, which add up to total of 42. So it could have been 9, minus 10, 20, 15. That is another path, but that value is up to 20 plus 15, 35 plus 9, 44 minus 10, 34. So this path is not the greatest, right? So the greatest path is 42. Hope this makes the problem statement clear. We have to find a path in the binary tree which has the maximum sum, and this path may not pass through the root of the tree. This path is from any two nodes of the tree. Now, since we got the problem, let's take this example here and work through it. Minus 10, 9, 1, 2, and let's make it minus 13, 20, 7, and 15. So this is our tree. Let's work out the solution from this tree, and then we will write the code for it. What we want is, at every node, we want to find what is the maximum value we can get in terms of path, right? So if I include a node into path, I cannot have this and this both, right? So the root can be added to this, or root can be added to this, right? What I will be doing is, I have to find to include, should I include the path coming from the left hand side, or should I add root to the path coming from the right hand side? So what I will be returning from each node, what we will be returning will be the max of the value which comes from the left tree and the value which comes from the right tree. Whatever is the maximum, I will add a root to it, and that will give me the maximum sum I can achieve by having this node in the path. Yeah, so that will I I will return to my parent. Every node will do that, right? That's the first thing. Now, what if the path has to be or can be from this node to this node? This is a perfect path, right? From this left subtree and this right subtree. So the path which comes from the right subtree, path which comes from the left subtree can be connected via the root node. So if I want to get the whole sum of this entire path, what it will be? It will be the sum which came from left hand side, the sum which came from the right hand side, and then root dot val. That is the whole sum of this particular path. What I will do is I will compare this sum with the global max. If the global max is less than this sum, I will update the global max. Otherwise, I will keep the global max as is, right? And of course, what I will return is max of L comma R plus root dot value. Why don't I return L plus R plus root dot value? Because from the parent, right, the path cannot be this node, this node, and this node. Path can be either this and this, or this and this, right? So I have to choose with whatever gives me the maximum. So if I have to go to the right hand side, I will choose that. I will make sure that the right hand side subtree gives me the maximum path, right? That's why it is chosen like this: maximum of L comma R root dot val. And why do we update the sum? Because the sum can be local in this whole left sum, right sum, and then add, and it may lead to a bigger sum. That's why we take the whole sum of the current node and then compare it with the max, right? One thing we have to do is there is no point adding the left hand side tree if the sum on the left hand side is negative, right? It will never reach more than the value of root plus right if this sum is negative. So for example, if this value was -1, right? So in this case, what will be the overall sum? 9 plus 2 minus 1, right? It would have been better if we just take this path, 9 plus 2, which will be 11. So if left becomes negative or right becomes negative, we will not take that sum into consideration while doing this equation. So we will take only the positive value of L and R. If the L and R are returning negative, we'll just ignore them. How do we ignore them? We can easily ignore them by just doing this. So whatever is max, we'll take it, right? Either 0 or the value. So if the value is positive, it will be taken. If it is negative, 0 will be taken. That is effectively saying that we are discarding the left subtree if the left subtree is negative. Or we are doing this. That is to say, we are discarding the right subtree sum if the right subtree sum is negative, because anything you add negative to the already existing sum, it will decrease the value and it will never lead to a global maximum. So we'll just drop it, right? So now we got the four different aspects of this problem, that how should we limit or how should we bound our sums coming from the left subtree and right subtree. How do we use it to calculate the global max? And what should we return at each node? At each node, we return what will be the maximum value of the path if this root is involved into the path. That's why root dot val and maximum coming from the right and the left, right? So let's code it. The code becomes very simple now if we know these four steps, right? So what we'll do is we'll say like, hey, integer max path, and we'll pass node root, right? And if root is null, we just return 0. But if it is not null, what we have to do is we have to find integer left, and as I said, what will be the maximum sum which I can get from the left hand side. If it is negative, I will just do the 0, and then I will call the maximum path because that's what I want from the left side. So I'll call it on left side. Similarly, I will do the right path. Math.max 0 comma, again I will call the same function on root dot right. So now we know what maximum path, maximum sum of path we can get from the left hand side. If it is negative, we'll give it 0. If it is what is the maximum path we can get it from the right hand side. If it is negative, we'll make it 0, right? The next thing is, what is the current sum? So current sum is L plus R plus root dot val. This will give us the sum of this whole tree, the path, right? Which will be compared with the existing max. If it is greater than the existing max, we'll just update the existing max. Next, now what we were supposed to return from the function, we would return what will be the maximum value we can get if this root is part of a path. In that case, what we will do is we'll return the maths dot max L comma R, either whatever comes maximum, either from the right hand side or from the left hand side, plus whatever my root value is, because my root will be added, and that is what the function will do. If you want to run on a example, let's run it. So let's run this -10, 9, 20, 15, and 7. Let's say this is our tree. So we call max path, node is 10, -10. So root is not null. We come here and we go for the maths.max 0 comma max path of 9. So we come here, the value is now 9. Root is not null. We go to the left hand side. Again, we try to find the max path from the left hand side. Here the root becomes null, so it returns 0. So 0 comma 0, the max for 9, the L for node 9 is 0. So we go to the right of node 9, which will again be 0. So R for node 9 is also 0. What we'll do is we'll do max of L is 0, R is 0, root value is 9, and max was initialized to, let's say, minimum integer value. So maximum will be updated to 9 now. And what will we return? We'll return maximum of 0 comma 0 plus 9. So this guy returns to the parent. What it should return? It returns 9. Great. So when you come here, L of 10 is actually now 9 because that's what we return, right? So we go into the R of 10, right? So root dot right. So we are here now, right? So 20. Great. Root is not null. We go into the left hand side of the 20. We come to the 15. 15 is not null. We go to the left hand side, which returns the 0. So L of 15 is now 0. We go to the right hand side. R of 15 is also 0. What happens here is max gets updated because L was 0, R was 0, this was 15, existing max is 9, so max becomes 15. Great. Now what will we return? We'll return L was 0, R was 0 plus 15. So it returns 15 to its parent. So L of 10 was 9, right? L of 20 became 15. Great. So now we'll go to the right of 20, right? So which will eventually return 7 as we saw. So R of 20 will be 7. Now we come here, L is 15, R of 20 is 7, plus root dot value is 20. So overall value becomes 42, which is greater than 15. So we update it. And what we return from this particular node is maximum of L and R. So maximum of 15 or 7 is 15 plus root dot val, which is 20. So we return 35 to minus 10, right? Now L of 10 was already known 9, and R of minus 10 is already known as 35. So what will be the max? Max will be 9 plus 35 plus minus 10, which adds up to minus 34, which is less than, plus 34, which is less than 42. So max will not be updated. And then we'll return from here the 35 comma 9, whatever is maximum, 35 plus minus 10, which is 25, which goes nowhere because we already have updated the global value. So the maximum path sum we can get in this tree is of value 42, which is this path, 15 plus 20 plus 7. Hope this explains the whole concept. This problem is very similar to the diameter of a tree. If you can just go back and revisit the problem of diameter of a tree, there also we get the diameter on the left hand side, diameter on the right hand side, and then we add 1 plus diameter of left, diameter of right, and then we return what is the length, maximum length, either on the left hand side or on the right hand side, plus 1 to the parent, right? More or less similar structure of the problem. These problems are very well known problems where the maximum or the global state is very different than what you are returning from each node. In this case, each node was returning what will be the maximum path if the root is involved in that, in case its parent gets involved or the involves the child node. So what will be the maximum path we can get? But the global state was the maximum path in the tree itself, not at the particular node, right? So the value you return from the node is very different than the global state, and that's what makes these problems, diameter of a tree or a max path in a tree, a very difficult problems. But if you first understand the whole concept, right, getting the L and R and what this function max path returns, these problems are like 4 lines of code as I showed. The complexity of this code is O of n because you will be going through all the nodes in the tree. That's why O of n. If you have any questions, feel free to reach out to me. I'll be happy to take a demo class or clear your doubts as soon as possible. Thank you very much.